So hey guys, welcome back to another lectures. In the previous lecture we have discussed the differentiation and integration, and we have discussed the introduction to the calculus. So today we're going to look at the functions. So what is a function? So the function, it defines the relationship between one variable and another variable, which is independent and dependent. So in our previous example, if we have a bike, that leads to 50 kilometers, and I have 1 liter of petrol. And it goes to 50 kilometers, and we have a 2 liter of petrol, and then it goes to 100. So the kilometers depends upon the liters of petrol, right? So the independent and the dependent variable, this is independent, means this is dependent, which means the kilometers are dependent upon the liters of the petrol which you pour in a bike, right? So I just want to give a better example, don't worry. So as of now, it defines a relationship between one variable, which is the independent variable, and another variable, which is dependent variable. So we have a function like this. So this is independent, and this is a dependent, right? So if I want to put a 2 or 3 or whatever it may be, these are the inputs, and we simply call them as the inputs, and we plug in these values right here. So these value depend upon this value, right? I hope you're having a good idea, means a better idea, right? So I hope you're having a basic idea like what is going to happen. So one depends on other. So the kilometers depend upon the petrol, the liters of petrol, right? So the function depends upon this value. I hope you're getting it. So we have a function over here. So we have a function, or x square or 2x square or whatever it may be. We have our 2x square plus 4, 2x plus 4, whatever it may be, is just a function, right? So we simply call this as a domain, and this we call as a range. So just remember these words, right? So this we call as a domain, and this we call as a range. So the set of all input values of a function is called as a domain. So the set of input values, right? So we have a x1, x2, x3, whatever it may be, the values like 1, 2, 3, 4, etc. These are all called as a domains, and the set of all input values are called as a output values. The set of all output values are called as a range of the function. So this is a range of function. If the x value is 2, then the x square become 2 square, and the 4 is the output. 4 is our output, and this is the range of the function. So the all inputs values are independent. So these are all independent, right? So it may be 1 or 2 or 3 or 4, whatever it may be. But based on this, the output is based on, if it is 2, then it will become 4, it will 3, it will become 9, it will 5, it will become 25, right? So it always depend upon these values, which is input variables. So they are independent, and output variables are dependent, right? So I have given examples, the same example, right? We have a f of function over here, and we have a x square here. So if I take our input variable 2, which is input, we just simply plug in the x value is equal to 2, and then we get our 4. This is our output, right? So this is our output, this is our range of the function. If we take our 3 value, if we take the 3, and then it will become 3 square, it will become 9. So this is the input, which is independent, and this is dependent, which is output and dependent upon the input variable. I hope you're having a good sense of the functions, right? So I just want to discuss composite functions. So what do you mean by a composite functions? So we have a two kind of functions. So we have I can say so we have a function here. So in that function I can have another function, right? So we have a g of x, or we can have another function in that g of x also. So we can have multiple functions in that one function. So that is called as a composite functions. Which means we can have one or more functions. We can have one or more functions in the single function. So in this example, we have another function, which is g of x in the f of x function. So just be familiar with the words which I am using. So we have a f of function here. In that x, we just replacing with g of x. We have another function. The x is g of x, and we have a function like f of g of x, right? or we can have a three functions like f of g of h of x, whatever it may be. It depends, right? It depends. So we have, this is called as a composite functions, like having one or more functions in the same function. I hope you're getting it. So the slope of the intercept function is y is equal to mx plus c, as we discussed in our previous lecture. So how we draw the line with the y is equal to mx plus c, etc. So here the m is slope and the c is the y intercept. So the c is the y intercept, and we have formula, right? So we have a formula in our differentiation, right? So y2 minus y1 by x2 minus x1. So we simply find those values. So as of now, just leave it. I'm going to cover here. I'm going to cover here. So as of now, just leave it. So I'm going to cover. I'm going to give a better example here. So we have a composite function here. If g is equal to 5x minus 8. If g is equal to 5x minus 8. So if g is equal to, so like if g is equal to 5x minus 8. So I'm going to plug the value 3 here. So it will become 5 into 3 minus 8. Then that will become 15 minus 8, right? So then that will become 7, right? So I'm getting a value of g value, right? So I'm getting the value of g of function, and then it directly become it inside the f function, right? So it is inside the f function, and the value become the x value. So the value of f is equal to 7. So the value of x is equal to 7, right? So in the f function we have a this. So if we plug in the value of 7 in the f of function, like f is equal to x square, right? So we just simply plug in the g value here. So which is like f of 7, right? So we just simply plug in this, and will become like the value become like 7 square, which is 49, right? I hope you're getting it. So we have a function, right? So we have a function like g of x. The g of x value is 7, and the f function which is equal to x square, right? So we just simply square the value, whatever it may be. So in this example, it has given this 7, or it may be have a 8 square, or 9 square, or whatever, 1 square also. It depends upon the solution problem. Okay. So I hope you have a basic intuition about the composite functions. Like composite functions means having a one or more functions in the same function, right? In the same function. So we just simply calculate these we simply calculate from the inner, like, so we just calculate the first, and then we come outside, and then we calculate next, and we then come outside. It's just a kind of that example. So so I'm going to look at this y is equal to mx plus c. So what is this y is equal to mx plus c? So how we draw that? So for example, we have a y is equal to mx plus c, right? So in a practical sense, I'm going to explain, like we have a y is equal to 3x plus 2. We have a y is equal to 3x plus 2. So how we draw a line from this equation? As I've said in our previous lectures, right? So please look into it. So otherwise I have explained here. So we take the x and y value here. So we just simply plug in the values. Like 0, 1, 2, 3, 4. I didn't want the negative line, means like I didn't want the negative line. So I just simply added the positive values, or you can add another values also. Just as of now, just ignore that. You can add -1, -2, etc. As you wish, right? So I just taken the 3 values, and I just simply plug in the x value here, and I get the answer 2, and the 2 value here, which is 6, and plus 2, which is equal to 8. So I hope you're getting, like, so we have a table here. So we just simply plot these values in the graph, okay, in the graph, and we get our line. So this is a linear equation of that line, y is equal to 3x plus 2, right? So this is the equation of line. So we just simply plot this. So this process to draw the line from the equation, this is the process, right? So this is the process, like how we draw the line from the equation. We just simply take out the table of that x value and y value. So we just simply plug in the equation. If we take a sample data from a series of equation, from the series of numbers, like from series of numbers like -2, -1, 0, 1, 2, 3. We simply plot these values, right? So we simply plot this, and we going to get the output values like y and we have a x value. So based on that, we have x value 2 and we have x value 2 and y value 2, and we simply plug in that, and we simply plug this. We just simply draw a line from it. I hope you're getting it. So what are composite functions, and how we find that, and we have seen how we plot that function, how we plot the function if you have a linear equation. So I hope you understand until now. So after that, I'm going to cover something known as parabola. So what is parabola? So I just want to research on your own. Just Google it. Are you going to get a lot of information? Just research about what is parabola and how the name came and etc. There is a lot of history out there. So I just want you to research about that. So I hope you do that, and I'm going to skip that part, and I'm going to give a practical example, right? So the parabola is a continuous function. It's just a continuous. It goes. It's just a continuous function. Okay. So if we have y is equal to x square or x cube, whatever it may be, if we have, for example, in our example, we have a x square, y is equal to x square. So as our previous example, right? So as our previous example, we just simply plug in the values, right? So we simply plug in these values in this. So we just simply plug in the x and y values like 1 2 3 4 5 6, and we just simply plug in the values here like 1, then 2 and 3 and 4, and then we're going to get our output like the y. So we just simply plot this and we get our parabola, right? So we simply get our parabola here. So the f of x, which is x, is the absolute value of x. Then the graph look like so like if the values of f of x is equal to the absolute value of x, so like if the values f of x is equal to the values of absolute values of x, then the graph look like this. It intersects here. It intersects in the origin. It intersects in the origin, which is 0, 0, right? As we discussed in our previous lectures. So it is 0, 0. So the both functions are symmetric with the respect to the y-axis. So these are symmetric. So these are symmetric means like if you put a mirror over here, so they are look like a same. I hope you're getting it. They look like same. Here, I'm so sorry about the parabola here. So this look like the same here. So if you just imagine we are putting a mirror over here. And this is similar to the another side of this parabola. So these are called as a symmetric function. Right? So we have two functions, as I said, like we have a even function, we have a odd function. We have a even function and we have a odd function. So what are even functions? So if the output, whatever it may be, if the output is going to be even, which is 2, 4, 6, 8, 10, etc., these are even functions. If the value is going to be like 3, if the power is 3, 5, 7, etc., like 3, 5, 7, 9, 11, etc., then we gonna call it as a odd functions. I hope you have a basic idea of that. So I just want to give an example like so here. So we have we have a function over here. So I'm going to find the parabola here. So we just simply take out the table like here, and when we have a x value and y value, and we're gonna plug in like so. I'm going to take 1, 2, 3, 4, etc. I'm just plugging the values, right? So anything is 0 and the value is 80 here. There is no calculation here. So I'm going to get I'm plugging the value of 2 over here. So the value of 2 power 4 is 16 plus 4 plus 8, right? So then it will become 28. The value become 28. If it is 3, then it will become what? It will become like 3 power 4 plus 3 power square plus 8. Then it will become, what is the value of 3 power 4? So the 3 power 4 is 81 plus 9 plus 8. Then that is equal to 98. So the values might look like big, but if we simply draw a line, if we simply draw a parabola, then we take the values based on the output, right? We just take out the values based on the output. So I'm gonna take 20 as here, 40, 60, 80, 100 and 110. Okay, 120, right? So I'm going to take here 1, 2, 3, 4, 5, etc. If we simply plot that, we're going to get something like this. So I haven't take the values of minus, but if I take also, if it is here, then it will become here, right? They are symmetric, right? So if I take the minus values, then I am going to get here like this. I hope you're getting it. So this is a simple example how we plot a parabola on the graph. I hope you're getting it. So I just want to recapitulate what I have said till now. So we have a composite functions, right? We have a composite functions. So what is composite function? So if we have a two or more functions in a same function, then we simply call it as a composite functions, right? So I explained how we plot the line from the equation. So I have given example of parabola and what is parabola, and how we plot the parabola by using the same as follows in a y is equal to mx plus c. So it just how why it is continuous. So I just want you to explore on your own, so that it is easy to remember if you explain on your own what is the symmetric parabola, which is similar if you look at the another side also. And I have explained here like in an even function. So I just want you to explore the odd function. This is the assignment. So the assignment is, so I just want to write here. So I just want to write, so the assignment is, research about the parabola. So the research about the parabola, and try different values and plot the parabola and plot the parabola. And I just want you to explore the odd function and plot it on your own, and try the three functions in the composite functions, like f of x, f of g of h of x, like this. I hope you do that, and I hope you enjoyed this lecture. So until then, bye bye, see you in our next lecture.